Hello, everybody. Let me see if I can switch so it doesn't do that. Okay, I figured out a way to show my face and what I'm writing at the same time so that it's, I don't know, more real, but it's good to for you to see me, I guess. I can't see you. Oh man. All right. I hope you guys are doing well. So today we are starting statistics. Um, So we're going to start off by talking about populations and samples. Okay. So a lot of these things that we're going to talk about today are subsets of one another. And yeah, so we're going to talk about those. Hopefully, you didn't have to watch the Discovery Ed video. That's in Activity 1. That's just like an extra supplemental thing. But you might know some of these if you have watched the Discovery Ed video. Okay, so we're going to talk about population versus sample first. Also, I probably should have put on my hair, like put on more than a sweatshirt, but whatever. Anyways, okay, so population is used when gathering data from every individual of interest. Okay, so this would be like polling for an entire football team. Okay, so not just like a couple people on the team. It's like asking every single person in a particular group a question. You also can take something called a sample, and this is used when gathering data from some individuals of interest. So this is when we take like a small group. So maybe we only poll the offensive, so polling only, sorry, the offensive linemen. Okay, so yeah, so we're taking like a subset of the group and we're just asking those people the question. You can do this with like groups of people in a community. So in a community, if you want to try to maybe gather data about an entire population, sometimes we use just a small sample to describe that. And that might be asking like maybe just every other house on a street or something like that. We're taking a smaller group so that it's less work and then generalizing that to every single part of the population. Now, the data that comes from either a population or a sample is respectively called a statistic. Oops, I see. Which is a descriptive measure computed from the sample of data. And I remember these by the first letter. A statistic comes from a sample specifically, and then a parameter comes from the entire population of data. So it's rare that we have a parameter where we can get every single person in a population to answer a question. But sometimes we can. And when we do, we call that a parameter. Okay. And then a statistic is just from a subset of that population. Okay. So, and then the last thing is inferential. You can hear my husband blowing the driveway off. He just cut the grass. Inferential statistics. It enables you to make the educated guess about a population parameter. So this is what I was just saying, based on a statistic computed from the sample. Okay, so from a population parameter based on a statistic computed from the sample. This is kind of like voting in the United States. Not everybody votes, unfortunately. So when we vote, we're kind of creating a statistic instead of a parameter. Voting is kind of a biased statistic because there are certain groups of people that do or don't vote or can or cannot vote. And so not everybody has access to it, so it becomes biased. But it's kind of an example of a parameter versus a statistic. So an inference means so to infer is meaning that we are taking what's true about a small sample of people, and I'm taking that and I'll assume that it's true about the whole population. Okay, so since we're making this assumption, it's really important that we try to not be biased when we're answering questions. So your warm up for today asked you how to remove the bias from the question, where do you like to party? So the issue with that question was it was assuming that you wanted to part or that you liked to party by asking the question where. Um, Maybe I don't like to party, so I can't answer that question because I don't party anywhere. So maybe a better question could be something like, do you like to party? Um, so we have to be careful about the ways that we gather data. So in a survey, we use a questionnaire to collect interesting data on a certain topic from a sample of people. Okay, so survey is just a little questionnaire. In an observational study, we are not asking any questions. We're simply observing stuff. Okay, so we're picking something to observe, and we're just like writing down little observations about it. So we observe individuals and measure variables of interest, but do not attempt to influence the responses at all. So in a survey, questions can cause a particular response to occur depending on the way that we phrase the questions. In an observational study, yes, your observations could be biased, but if you're just checking off specific variables, then it has the potential to be less biased. These may show a correlation between variables, but not always guarantee causation. Okay, so maybe CO2 levels, the amount of gas that we emit, the pollution that we emit, may be a large factor in global warming, but we can find strong correlations between the two. The more CO2 we produce, the higher the world's temperature get. But it might not necessarily be the only cause. So we can't conclude direct causation. In an experiment, we deliberately impose some treatment or we basically change one of the variables. We have a dependent variable on individuals in order to observe their responses. These can carry on more convincing evidence of cause and effect relation. All three of these things, survey, observational study, and experiment, can be biased, but can also be created so that they aren't biased. So the different ways we can sample, we can have random sampling. My dog is like rubbing her face on the carpet. Okay. So random sampling is when everyone in a population has an equal chance of being chosen in an experiment. So for example, when I draw your names back when we were in the classroom out of the cup, at school, each of your names were in the cup. It was only in there one time. I drew it randomly. So that's a random sample. Everybody had an equal chance of being drawn. Stratified sampling is when the population is first divided into similar categories, and the number of members in each category is determined. So maybe they come up, I need to actually come up with an example. So they come up with like different categories and maybe they take four people from each of those categories to just the left. Okay. So similar categories. I'll think of an example in a little bit. The next one is a systematic sampling. Okay, when you determine a method for which to choose members of the population, so assign numbers to the population and then choose every fifth person to participate. So we would assign, maybe you go down a street and you list the houses 1, 2, 3, 4, 5, and you're going to pick every fifth person or household to participate in whatever you're doing. Cluster sampling. When you randomly put the population into clusters and then choose a cluster randomly, then randomly choose people from that cluster to participate. And the last one is convenience sampling. This is when we choose our sample based on what's easiest to do or a smaller group that already exists. So maybe you stand in the doorway and just like grab people as they go by and ask them a question, give them a survey. That would be convenience sampling. I didn't write examples for all of those, but you guys will have a practice assignment that will have examples in there. I think that the different types of sampling are probably the hardest things to try to differentiate between, but we're going to go through them. So just try your best. Good luck. I'll see y'all later.